The 6 stages of AI agent development, beyond plug and play. Introduction: why AI agent development requires strategy. Building AI agents is fundamentally different from traditional software development or simple plug-and-play solutions. The comprehensive framework demonstrates successful AI agent development demands a dedicated strategy that goes far beyond just selecting frameworks and large language models. The reality is that developing effective AI agents requires understanding the wider scope of your use case, carefully considering stakeholders' decisions, and following a structured methodology that addresses both technical and business requirements. Today, we'll walk through the 6 critical stages that transform an AI agent concept into a production-ready, scalable solution. Stage 1: Planning, foundation for success. The planning stage sets the trajectory for your entire AI agent project. This isn't just about technical specifications, it's about creating a comprehensive roadmap that aligns technology with business objectives. Draft business needs. The first critical step involves identifying the core business problems your AI agent will solve. This goes beyond surface-level automation to understanding the deeper organizational challenges and stakeholder decisions that drive the need for an AI agent. Ask yourself, what specific pain points are we addressing? How will success be measured? And what are the expected outcomes? Define agent objectives. Once business needs are clear, you must specify the goals and intended capabilities of your AI agent with precision. Vague objectives lead to scope creep and failed implementations. Your agent objectives should be specific, measurable, and directly tied to business outcomes. Resource allocation. Successful AI agent development requires careful allocation of personnel, budget, and compute infrastructure. This stage involves assessing what technical talent you need, estimating computational requirements, and ensuring adequate financial resources for the entire development lifecycle, not just the initial build. Risk and ethics review. Perhaps the most overlooked aspect of planning, the risk and ethics review assesses potential ethical concerns and compliance risks before development begins. This proactive approach prevents costly revisions later and ensures your agent operates within acceptable legal and organizational boundaries. Stage 2: Design, architecture for reliability. The design stage transforms your planning insights into a concrete architectural blueprint that balances capability with safety. Design guardrails. Before building any AI capabilities, you must architect limits and constraints to prevent unintended behavior. These guardrails act as safety nets, ensuring your agent operates within defined parameters even when encountering unexpected scenarios. Think of guardrails as the ethical and operational boundaries that keep your agent aligned with its intended purpose. Choose a framework. Framework selection significantly impacts development velocity and long-term maintainability. The choice depends on your specific requirements. Do you need multi-agent coordination? What level of customization is required? How important is community support and ecosystem compatibility? Select a model based on workflow. Model selection should be driven by workflow requirements rather than just performance benchmarks. Consider factors like latency requirements, accuracy needs, cost constraints, and integration complexity. The best model is often the one that best fits your specific workflow, not necessarily the highest performing one. Grounding with context. This critical step involves integrating domain knowledge and relevant data into your agent design. Context grounding ensures your agent understands the specific environment it will operate in, including industry terminology, business processes, and organizational culture. Stage 3: Development. Building with precision. Development is where your design comes to life through careful implementation and integration. Build the agent logic. Implementing the core logic, rules, and reasoning system requires translating your design specifications into functional code. This involves creating decision trees, workflow orchestration, and the fundamental reasoning capabilities that will drive your agent's behavior. Integrate the models. Model integration goes beyond simple API calls. It involves creating seamless connections between your chosen AI models and your agent logic. This requires careful attention to data formats, error handling, and performance optimization. Fine-tune models if required. When pre-trained models don't quite meet your specific requirements, fine-tuning becomes necessary. This process involves refining models using your specific datasets to improve accuracy for your particular use case. However, fine-tuning should be approached strategically. It's not always necessary and can introduce additional complexity. Document setup. Comprehensive documentation of all technical configurations, workflows, and logic is essential for future audits, maintenance, and team onboarding. This documentation becomes invaluable when troubleshooting issues or scaling your system. Stage 4, testing, validation, and verification. Testing AI agents requires a multifaceted approach that goes beyond traditional software testing methodologies. Evaluate performance. Performance evaluation must be based on predefined metrics that align with your business objectives. This isn't just about technical performance, it's about measuring how well your agent achieves its intended business outcomes under various conditions. Perform integration tests. Integration testing ensures seamless data flow between your agent and other systems in your technology ecosystem. This includes testing API connections, database interactions, and compatibility with existing workflows and tools. Conduct user experience tests. User experience testing validates that your agent offers an intuitive experience to end users. This involves testing the interface, conversation flows, response times, and overall usability. Remember, even the most technically sophisticated agent fails if users can't effectively interact with it. Test edge cases. Edge case testing simulates rare or extreme scenarios to check your agent's robustness. This is particularly critical for AI agents because they may encounter situations not represented in training data. Edge case testing helps identify potential failure modes before they occur in production. Stage 5, deployment. Launch with confidence. Deployment marks the transition from development to production, requiring careful orchestration of technical and operational elements. Launch agent. Releasing your AI agent into the production environment requires careful planning and execution. This involves configuring production infrastructure, setting up data pipelines, and ensuring all integrations work correctly in the live environment. Make sure guardrails are working. Post-deployment verification of guardrails is crucial. You must confirm that your safety mechanisms trigger and respond correctly in the production environment. This isn't just a one-time check. It requires ongoing monitoring to ensure guardrails remain effective as your agent encounters real-world scenarios. Observability. Setting up comprehensive monitoring, logging, and tracing pipelines allows you to track agent behavior and performance in real time. Observability is particularly important for AI agents because their behavior can be less predictable than traditional software systems. Compliance validation. Final compliance validation ensures your deployed system meets all legal and organizational policies. This includes data privacy requirements, industry regulations, and internal governance standards. Stage 6, maintenance. Continuous evolution. Maintenance ensures your AI agent continues to deliver value and remains aligned with evolving business needs. Monitor agent objectives. Regular monitoring checks whether your agent still aligns with its original purpose and business objectives. Business needs evolve, and your agent must adapt accordingly. This involves periodic reviews of performance metrics and business outcomes. Optimize operations. Operational optimization is an ongoing process that fine-tunes performance, reduces costs, and improves efficiency based on real-world usage patterns. This might involve model updates, infrastructure scaling, or workflow improvements. Act upon user feedback. User feedback provides invaluable insights for iterative improvements. Establishing feedback loops and regularly incorporating user insights ensures your agent evolves to better meet user needs and expectations. The strategic imperative. This 6-stage framework reveals why AI agent development requires more than just technical expertise. It demands strategic thinking, cross-functional collaboration, and a commitment to continuous improvement. Key success factors. Holistic approach. Success requires considering business needs, technical requirements, user experience, and operational realities from the beginning. Stakeholder alignment. Regular communication with stakeholders throughout all stages ensures the agent delivers real business value. Iterative improvement. AI agents improve through continuous learning and optimization based on real-world performance and feedback. Risk management. Proactive risk assessment and mitigation prevent costly issues and ensure responsible AI deployment. Beyond frameworks and LLMs. While frameworks and large language models are important components, they represent just the tip of the iceberg. True success in AI agent development comes from understanding the broader organizational context, designing for reliability and safety from the beginning, implementing comprehensive testing strategies, planning for long-term maintenance and evolution, ensuring continuous alignment with business objectives. Conclusion: a methodology for success. The 6-stage AI agent development methodology provides a proven framework for transforming AI concepts into production-ready solutions. Each stage builds upon the previous one, creating a comprehensive approach that addresses both technical and business requirements. Organizations that follow this structured approach are more likely to deliver AI agents that not only work technically, but also provide sustained business value. The key is recognizing that AI agent development is as much about strategy, planning, and ongoing management as it is about coding and model selection. As AI agents become increasingly central to business operations, this methodical approach will separate successful implementations from failed experiments. The future belongs to organizations that can master not just the technology of AI agents, but the discipline of developing them strategically and systematically.